Hello everyone, welcome to our new video about linear equations and inequalities. We saw that this is for the SAT math section. We have already seen these topics on previous videos. Right now, we're gonna check out different examples so that we can practice on them. So let's start with our first one. You guys already know the basics? If you don't, well, don't worry. This video is for beginners. It's about examples after all. Our parent statement will be 3x plus 2 is equal to 11. First of all, this applies to any linear equations or any inequalities. We must put the x's or the variables, for example, I'll put an x in one side and the constants, I'll put it in an a or a number in the other side. If that is true, then we grab the 2 and we put it to the other side to subtract since it is adding. And so 3x will be equal to 11 minus 2. 3x will be equal to 9, and so if 3 is multiplying the variable, it will pass to the other side to divide, so that the variable remains isolated in one side of the equation. X is equal to 9 over 3. Perfect. What is the third part of 9? It is 3. What is the third part of 3? Well, 1. And so x is equal to 3 over 1 or 3. That was our first example. Now what about our second? This one is going to be about an inequality. 2x minus 5 is lower than 7. And so we will see the lower, the greater or equal than, or the lower or equal than. Okay. Basically, if we have the 5 here, what do? Well, we pass it to the other side. Of course, it is subtracting, right? So we pass it to the other side to add. 2x will be lower than 7 plus 5. 7 plus 5 is 13. Alright, now the 2 passes to the other side to divide since it's multiplying. X will be lower than 13 over 2. Now, this is a problem. One with a solution, of course. Maybe the SAT will give you this option, but maybe it wouldn't. So now you have to divide, since 13 is not a multiple of 2. And so we do the following. We start dividing by hand, because of course calculators may not be allowed in this part. So 13 divided by 2, right? What is the lower number closest to 13 that is a multiple of 2? It is 12, right? And 2 by what number equals 12? Well, it would be 6. 13 minus 12, 1. Then you put a comma, then you put a 0 to it. And 2 by 5, we already know that is 10. And so we have a remainder of 0. And over here, 6.5. X will be lower than 6.5. That will be the most prevalent option that may appear either in decimals or in fractions. In any case, you must be prepared with both. Now, what about the third example? Which is, of course, another linear equation. This says the following. 4x minus 8 equals 12. Then again, what's the value of x? Alright, we pass the 8 to the other side to add, right? Since it's subtracting. So, 4x is equal to 12 plus 8. 4x will be equal to 20. 4 is multiplying, it passes to the other side to divide, and so x will be equal to 20 over 4. Alright, simple enough. What is the middle of 20? It's 10, right? What is the middle of 4? 2. Middle of 10? 5. And middle of 2? 1. 5 over 1? It's 5. So x is equal to 5. Now, you have a question. Is that correct? Well, to test if that's correct, we must check. So you write the parent statement, but do you substitute the x's with the number you got? So 4 by 5 would be 20 minus 8 is equal to 12, right? So 20 minus 8, it's 12, and 12 is equal to 12. So it is correct. Now let's pass to the fourth one, which is an inequality, and the parent statement is 5x plus 3 greater or equal than 18. Of course, we do the same thing we always do, but this time, do it first, and then I'll do it. You finished? Alright. 3 passes to the other side to subtract, meaning that 5x is greater or equal than 18 less 3. 5x will be greater or equal than 15. X will be greater or equal than what number? 5, you remember, is multiplying, so it passes to the other side to divide. And so it would be 15 over 5. X will be greater or equal than 5 plus 5 plus 5. Well, it's 15. You get the idea. 5 times 3, it's what we need to get to 15. That's the answer. Let's go with a fifth one for the linear equation. We have minus 2x plus 7 equals 3. You may wonder, this is so simple. Why do we have to start with this? After all, the SAT is about graph analysis. So the 7 passes to the other side to subtract. That is the same. So negative 2x is equal to 3 minus 7. Negative 2x will be equal to negative 4, and so x will be equal to negative 4 over negative 2, of course, since it goes to divide or to the other side, and we cancel out the signs. X will be equal to 2. So how would be the graph for a linear equation in this case where we have x is equal to 2? The line will be present everywhere in the y-axis but only touching the x-axis on the number we had, which is 2. For our sixth example, we have x over 2 plus 4 greater than 5. Simple. We pass the 4 to the other side to subtract. We get x over 2 greater than 5 minus 4. X over 2 greater than 1. And so, since we now have a divider, we pass it to the other side to multiply. And so, x will be greater to 1 times 2, giving us a result of 2. Now, demonstrated on a number line, what does that mean? For this sixth question, or for this sixth inequality we know that a number line is made out of a 0, infinity to the right, and negative infinity to the left. If we have that x is greater than 2, in this point right here, where 2 stands on, well, x is gonna have all of the numbers after 2, but it won't touch 2. Why wouldn't it? Well, because it is not greater or equal than 2. If it means that it's only greater, then it would be only taking values from 2, 0, 0, 0, 0, 1, and so on, until reaching an inconclusive and incoherent infinity. We're just missing only 2 simple examples. For the seventh, it would be a linear equation. It says 6x minus 15 is equal to 21. So, pass it to the other side to add. If you already know how to do this, well, the answer will be right along the way. 6x is equal to 21 plus 15. 21 plus 15 is equal to 36. And so, we pass the 6 to the other side to divide. X is equal to 36 over 6. Is 36 a multiple of 6? That is the big question, and it is. So, how do we do this? You can either divide or simplify. For example, right now we're gonna start simplifying. The third part of 3 is gonna be 1. The third part of 6 is gonna be 2. The third part of 6 is gonna be 2. And so it is x is equal to 12 over 2. 12 over 2, 6. And there you have it, x is equal to 6. On a graph, it would look like this. Now, what about the eighth and last one? Well, it's gonna be 3x plus 2 lower or equal than 10. We pass the 2 to the other side to subtract. 3x is lower than 10 minus 2. Of course it is. Who am I to even say that? 3x is lower or equal than 8. What happens here? Well, x is gonna be lower or equal than 8 over 3. And oh geez, this is difficult, because 8 is not a multiple of 3. And if you see, well, in the last one, we had to use a division. In this case, you also have to divide. Of course, 8 divided by 3. What is the lower number that is closest to 8 and that is multiple of 3? It's gonna be 6, right? Because 9 surpasses 8. Since 3 times 2, we get 6. 8 minus 6 is actually 2, right? Since 3 doesn't fit in 2, you put a comma. Put a comma to add a 0 at the end of the number. So it's gonna be 20. What is the lower number closest to 20 that is multiple of 3? Gonna be 18. And if 3 times 6 equals 18, then the 6 goes up. Difference is gonna give us 2 again. And so it's gonna be 20 minus 18, 20 minus 18, and so on. So basically, we've got 2.66666 until infinity. It would be a periodically infinite number. Alright, so x will be lower or equal than 2.6. So you either put 8 over 3 or 2.66. Alright, so now what are we missing? We are missing a number line, of course, for the number 8. We know that here is 0 and 2.66, let's say it's around here. if x is lower or equal than 2.666. That means that it takes this entire spot, it takes the entire 2.666, and it takes everything that is lower than it. Lower than it means that it's to the left, alright? That is lower. That while greater than means to the right. That is the principle. That is the fundamental. So, how was it again? Pick up your notes and tell me if lower than will be to the left and greater than will be to the right. It won't touch a number unless it says lower or equal than or greater or equal than. Only if it says or equal than, then it will touch the result we just got. Having said all that, thank you all for watching. I just solved 8 different equations. I hope that served. Linear, inequalities, everything. We'll go to advanced in the next video, so stay tuned. I'll see you next time. So